In yesterday's lecture, we have seen the piston, the function of the piston, then design requirement of the piston. Also, we have seen the piston head. The piston head, we have seen the strength of the piston head and heat dissipation of the piston head. When you calculate both value as per the strength and as per the heat dissipation of the piston head, which value you will get greater, this value you should choose for the design. Yesterday we have seen the formulas of the as per the strength and as per the heat dissipation. Then also we have seen the piston ribs and cup. Also you have to calculate the total rib thickness. Okay, the thickness is greater than 6 mm and the greater thickness is less than or equal to 6 mm. Yesterday we have seen the radius of the cup also. Okay, that thing yesterday we have discussed in details. Today we will going on the piston ring. Also yesterday's lecture I have told is the piston ring. Okay, piston ring put into the two groups. Okay, first is a compression ring. See, in the figure I have shown the top compression ring, and second is a second compression ring is there. Also you have to use the oil control ring. Oil, it is also called as a oil scraper ring. Okay, in the compression ring are placed in the groove provided on the piston barrel. Okay, the function of the compression ring is to seal the space between the piston and piston cylinder liner, and to prevent the leakages of the gases passed in the piston. Then second function is to transfer the heat from the piston to the cylinder wall. Okay, remember that function in the compression ring. And second is a oil control ring or oil scraper ring. The oil control ring function is also placed in the groove provided on the piston barrel, are located below the compression ring. See in the figure here, name is given expanders oil ring rails. Okay, the function of the oil control ring to scrap the lubrication oil from the surface of the liner during downward stroke, minimize the leakage of the lubrication oil from the piston. Okay, remember that these two functions are given for the compression ring and oil control ring. Then next, which type of the material is used? We have seen there are two types of the material is used. The material having the good wear strength, the cast iron material and alloy cast iron. Okay, containing the nickel, chromium and palladium are used as the material of the piston ring. Yesterday we have seen that thing. Then see we have find out the formulae, number of piston rings in the compression ring and oil scraper ring. For aircraft and automobile engine, 3 to 4 piston ring will use compression ring, and for stationary engine we will use the 5 to 7 ring. Then next is a oil scraper ring. We will use the 1 to 3 rings. Then next, dimension of the cross section of the ring. See, we want to calculate the radial thickness of the piston ring. It is denoted by the TR, radial thickness of the cross section of the when you taken the cross section of that ring, then you will get the TR is equal to D into root of 3 PW divided by sigma all. Okay, sigma all. Allowable bending stress is given for piston ring. This is in Newton per mm square. This value is in between, or it is also called as the radial width of the you can calculate the TR and radial width of the ring. Okay, Pw is the radial wall pressure between the piston ring and cylinder wall. This is also given 0.03 Newton per mm to 0.062 Newton per mm. Tr is the radial thickness of the piston ring. And how to calculate the radial width of the ring? Radial width is denoted by the Br. This is given d into root of 3pw divided by sigma t. Okay, with the help of that formula you can calculate the radial width of the ring. So we have seen the z is equal to number of rings. Okay, axial thickness of the ring, which is equal to 0.7 b to b. H minimum is d divided by 10z. This is the axial width of the piston ring. It is denoted by the Br. Okay, width of the lands on piston between the rings groove. Okay, this B1 is a 0.75 to 1 Br bar 1 bar Br. Okay, width of the top land means BO is equal to 1 to 1.25 T again, 1 to 1.25 T. TPH is the thickness of the piston head. Then see the gap between the rings end. This is the GR. This gap is a 3 to 4 TR. Okay, 4 to 3 to 4 TR. Gap between the free rings end should be sufficient such that under the working condition, even a highest temperature, the ends should not touch each other. It is given by GR. GR is equal to 3 to 4 TR gap. Okay. Then width of the top land and ring land. Okay, there are two types, top land and ring land. This width will calculate H1 and H2. Okay, H1 is equal to TH2 1.2 TH. This value is given, and H2 is equal to, shown in figure, check that, H2 and H1 distance shown in figure. Okay, H2 is equal to 0.75 H to 1 H. Okay, then see the piston barrel. What is mean by piston barrel? Okay, the piston barrel are support the piston head, right? This piston barrel we have seen in the main figure in the first lecture. Piston barrel is support to the piston head and provide the seat for the piston ring. Below that piston barrel there is a piston ring, and this barrel is sit on that piston ring for effective heat flow. Okay, the thickness of the piston barrel is denoted by the TPH. Under the ring is equal to the thickness of the piston head, TPH. Then we want to calculate the thickness of the piston barrel at the top end and at the open end. There are two ends. At the top end this is denoted by the T3. Okay, this value is how to calculate. With the help of radial width we can calculate the thickness of the piston barrel at the top end. T3 is equal to 0.03 D plus B is the radial width of the ring plus 4.9. Remember that formula. You will get the thickness of the piston barrel at the top end. Okay, then T4 is the thickness of the piston barrel at the open end. This value also given in mm. How to calculate this value? Once you have calculated the thickness of the piston barrel at the top end, with the help of that you can calculate the value of thickness of the piston barrel at the open end. Then it is denoted by the T4. T4 is equal to 0.25 T3 minus 0.35 T3. Okay, with the help of that formula you can calculate the piston barrel. Then next is a piston skirt. Okay, what is mean by piston cuts? The portion of the piston cut, the piston barrel below the ring. Okay, we have seen in the main figure, this portion of the piston cut is placed below the piston barrel, the ring section. up to the open end, this portion is known as a piston skirt. This portion is known as a piston skirt. See this portion in that figure, I have shown that piston skirts portion. Okay, then the piston skirts is acts as a bearing surface for side thirds. Okay, bearing surface for connecting rod. Where is the connecting rod is joint, that side thirst we are getting the bearing surface. Okay, the bearing pressure due to the side thrust is less than 0.25 MPa, and this is the use for the high speed engine. Its length should be such that bearing pressure between the piston skirts and cylinder wall due to the side thrust should not be exceed than 0.3 Newton per mm square. They are using the for the low speed engine, and 0.5 Newton per mm square we are using for the high speed engine. 0.5 Newton bearing pressure due to the side thrust is less than 0.5 MPa in the high speed engine. Then see the maximum side of the thrust is denoted by the Rn. Okay, with help of that you can calculate Rn value, maximum side thrust. The formula is 0.05 to 0.1 into maximum gas force. How to calculate the maximum gas force on the piston head? You know that pi by 4 into d square into p max, already we have seen. Then you will get that Rn value is equal to the LP is the length of the piston skirt. Okay, and PBE is the permissible bearing pressure between the piston skirt and cylinder wall. Okay, this given in Newton per mm square. We have seen that two equation, Rn is equal to LP into PBE, and Rn is equal to 0.05 to 0.1 into pi d square divided by 4 P max. Okay, then you can calculate the length of the piston, the skirt. Okay, length of the piston skirt. How to calculate that skirt's length? You know the S1 is equal to S2, means width of the top length plus total width of the piston ring plus total width of the land plus length of the piston skirts. Okay, if you are making the summation of that all, then you will get the length of the piston. This is denoted by the LU. This is denoted by the LU. Okay, with help of that you can calculate the length of the piston is taken as 4 is equal to 1 to 1.75 d. Okay, S1 is the side stud. How to calculate? Mu into pi d square divided by 4 into P max, area into P max. This mu value is 0.1. This Poisson's ratio is depend on the types of the material, and S2 is the side thrust. PB into D into LS. PB into D into LS. Okay, this value you can calculate with the help of that formula. Then piston pin. Okay, next is a piston pin, or it is also called as a gudgeon pin. Before going on that, we have seen the reciprocating ribs. Okay, reciprocating ribs. See, reciprocating ribs. Okay, one by one. Piston ring. Before that we have seen the piston ribs and cup. There are some limitations we have seen. This TH is greater than 6 mm, means ribs are required, and here TH is less than or equal to 6 mm, ribs are not required. Remember that relation we'll use here. Then piston and piston pin. Okay, what is the piston pin or gudgeon pin? Piston pin or gudgeon pin or wrist pin, sometimes it is called it is also called as a wrist spin. Wrist pin, okay, is the link between the piston and the connecting rod. Piston and connecting rod. Okay, The thrust developed by expanding gas is transferred from the piston to the connecting rod. The gas should be transferred in between. The expanding gas is transferred from the piston and the connecting rod through the piston pin or gudgeon pin. Okay, we'll see the details. Types of the connection between the piston pin and piston. What is the relation in between the piston and piston pin? There are three types: full floating, semi floating, and third is a fixed. Full floating means in this type the piston pin is free to rotate both in the piston boss and the small end bush of the connecting rod. The end movement of the piston pin in the piston loss is restricted by using the circle at the ends. Okay, see that there are two circles. Snaps rings are connected to the piston pin. Okay, in between that there is a piston pin and there con rod is there. Semi floating, the piston pin is free to rotate in the piston boss but is clamped or fixed in the small end of the connecting rod. Okay, and third is a fix. In this type the piston thing is fixed in the piston boss but is free to rotate in the small end of the connecting rod. Then what type of the material we use for the piston pin? The material used for the piston pin are plain carbon steel and alloy steel. We are using the plain carbon steel or alloy steel. Okay, there is a contain nickel, chromium and palladium. Okay, remember that. The pin is hardened and ground and it turns in high grade bronze bush. Okay, this type of bush we are using. Two criteria: bearing and bending. Connects piston and shear. End movement is restricted by the circle. Then we will see the design of the piston pin. Design of the piston pin. There is a piston boss is there. Small end are connected to the connecting rod. Okay, there is a piston pin side in between the piston boss and cylinder. Okay, connecting rod. In order to offset the turning effect of the friction, the center of the piston pin should be the 0.03 D above the center of the piston skirt. Okay, see, we will keep that distance 0.03 D. Okay, the piston pin see in the figure supported in the piston boss. There is a relative motion between the pin and the bronze bush. There is a bush is there. Okay, bush is fitted inside the small end of the connecting rod. See, small end of the connecting rod, air pressure is given P. In order to reduce the weight, the pin is usually made hollow. Hollow portion is there. The maximum load acting on the piston pin is maximum gas force. Gas force shown by the P. Okay, which is given by Fg max is equal to force on the piston. Fg max, it is denoted by the Fg max, or we can say the force on piston is equal to pi by 4d square into P max. The piston pin are subjected to, there are a bearing pressure, direct shear stress and bending stress. Remember that. Okay, the consideration: the piston pin is generally designed from the bearing pressure consideration and then check for the direct shear stress and the bending stress. Means dp is the diameter of the piston pin, then di is the inner diameter of the piston pin. Okay, see that notation I have shown in the figure. And length of the piston pin in the connecting rod bearing, this is given in mm, and capital D is given piston diameter. This capital D is given for the piston diameter. Then considering the bearing pressure between the piston pin and the connecting rod bearing, Fg max is equal to L1 into Pb1 into do. Okay, use this formula. This is the resisting force. Pb is the permissible bearing pressure between the piston pin and the small connecting rod. Its values are given from the in the table. With the help of that table, you should check the bearing material and related that bearing material. You will get the value of the PB. Okay, value permissible bearing pressure value you will get as per the material. If there is a aluminium alloy, then this PB value is given in Newton per mm square 5 to 10. And if you have given the cast iron, again this value will change. You will get this value in between 10 to 15. Okay, 10 to 15. Remember that. As per the material, this value will be changed. This value will be changed. Then see here you have given some relation. Mean diameter of the piston boss is equal to 1.5 for DO for the GCI material, cast iron material, is equal to 1.5 DO for the alloy material. And you know the relation between DI is equal to 0.6 DO. 0.6 DO. Okay. Direct shear stress inner diameter of the piston is taken. This Di is equal to 0.6 DO for the direct stress, shear stress. Okay. Then this Fg value, force on the piston, will be changed. You will get the 2 into pi by 4 to bracket dp square minus di square into tau. Okay. This value will be changed. The consideration of the direct shear stress. Similar way, bending stress consideration. Okay, in order to check the piston pin for the bending, it is assumed that the maximum gas force acts as a uniformly distributed load over the length. Length is a, we are consider the 1k. Okay, and the pin is supported to the center of the bosses at the both end. Okay, then approximately length you can calculate. L2 is equal to L1 plus D minus L1 divided by 2 is equal to D plus L1 divided by 2. With the help of that formula you can calculate the length. But you know the maximum bending moment, the mid section of the piston pin. How to calculate this? You have learned in the some subject also how to calculate the maximum bending moment. Sigma is equal to m by z. Also we have seen the design of cylinder and pressure vessel, how to calculate the maximum bending moment or stresses induced in the cylinder. Here we want to calculate the maximum bending moment induced in the piston. Okay, then sigma b is equal to mb divided by z. Okay, then you know the z is equal to I by y. Again mb is equal to pd divided by 8, and I is equal to pi do raised to 4 minus di raised to 4 divided by 64 because of hollow portion. Okay, then sigma b for the case of the hardened steel. If the material will change, then your value of the sigma b also will change. See, here hardened steel is given, sigma b you will get the 84 Newton per mm square, and for the heat treated alloy steel you will get the sigma b is equal to 140. Then next is a piston clearance. Okay, this clearance is a 0.0375 to 0.1875 mm. Okay, what is mean by piston clearance? There is a relative sliding motion between the piston and the cylinder liner. In between piston and cylinder liner, there is a small motion, sliding motion. This is called as a piston clearance. The diameter of the piston has be marginally less than the bore of the cylinder liner. Need of the why we need the piston clearance? Because of thermal expansion of the piston and distortion of the piston under the load. Okay, we want to the provide between the piston and liner of the due to the this two reason. Okay, thermal expansion of the piston means what? Due to the high temperature of gas, there is a thermal expansion of the piston take place. Okay, the adequate clearance is not provided, the thermal expansion of the piston may be lead to the seizure of the piston. In addition, providing the piston clearance, okay, and the distortion of the piston under load. The distortion of the piston may be take place under the load near the piston pin. Piston pin. If the clearance is not provided, this may lead to the again seizure of the piston. Okay, relieving the side of the piston near to the piston pin and providing the piston slightly oval shape. Okay, this two reason you should remember that that's why we are provided the piston clearance. This piston clearance are recommended as per the material. Again, if you remember that there are different types of the parts are used for the piston. Suppose piston barrel is there and we are using the cast iron material for the piston barrel, then this value will be changed. You will get the this value 0.05 to 0.007 d. Okay, if you are using the aluminum material for the piston barrel, again this value will change. You will get the 0.01 d. As per the material, this all value will be changed. Okay, remember that. Okay, all of you getting. Today we have complete the piston parts, then we will see the numerical on the piston. Okay, design of piston. There is a, see what is the given. Here is a 4-stroke engine is given, diesel engine. The value of the cylinder bore is given to 50 mm, length of the stroke is given 300 mm, speed is given 600 rpm, indicated mean effective pressure is given 0.6 MPa, mechanical efficiency is given T, maximum gas pressure is given 4 MPa, fuel consumption is given 0.25 kg BP per hour, and HCV is given 44,000 kilojoule per kg. Then 5% of total heat developed in the cylinder transmitted by the piston. Okay, piston material is Fg 200, means SCUT value is given 200 MPa. K is 46.6 watt per m degree Celsius, and factor of safety that 5 is given. Temperature difference between the center and edge of the piston is given 220 degrees Celsius. Calculate what we want to the calculate thickness of the piston head by temperature and strength consideration. Second, which criterion decide the thickness of the piston head. Then third, state whether the ribs are required. Okay, we want to the check ribs are required or not. State whether the cup is required at the top of the piston head, or what is the radius of the piston head. We want to the calculate all these things. How to calculate? We have seen the design of piston, also thickness of the piston. How to calculate? As per there are two consideration. First is the strength and second is a thermal or heat dissipation. Both things we have seen, both formulae we have seen. We will calculate and we will check which is the greater value. TH is equal to D into root of 3 P max divided by 16 sigma B. Okay, if you are putting the value in that equation, see P max is equal to given maximum pressure 4 MPa 4, and sigma B is given is equal to sigma T is equal to SUT divided by factor of safety. Factor of SUT 200 and factor of 55. Then put the value, you will get the sigma B or sigma T 40 MPa. As per the strength, thickness of the piston head is 35 MPa. Thickness is a 35 mm. Okay. Then thermal consideration, how to calculate. TH is equal to H divided by 12.56 K into bracket Tc minus T into 10 raised to 3. Put all the value. H is given. Okay. How to calculate the indicated power? You know the formula, Pm LAN divided by 60. Put all the value in that equation and calculate the IP value. Then we know the efficiency is equal to BP divided by IP. You will get the BP value. BP is equal to efficiency into IP. You will get the 35.34 kilowatt, and M is equal to 0.25 divided by 3600 mass kg per BP per second. Okay, H is equal to C into SCV into M into BP. This value you will get in the watt. Okay, 5398.82 watt. If you are putting all this value in that equation, then you will get the thickness is a 42 mm. With the help of strength, you will get the thickness 35, and with the help of thermal consideration, you will get the 42 mm. Then when you design the piston head, then you should take the 42 mm because of safety of the piston. Then we want to calculate the piston rib. Okay, the piston rib is greater than 6 mm. Rib are required. We have seen there are two relation, when ribs are required and when ribs are not required. If the greater than 6 mm, then ribs are required. Then we will see the formula TR is equal to TH divided by 3 to TH divided by 2. You will get the 14 to 21. Then TR is equal to 18 mm. 18 mm. Requirement of a cup: L by D ratio, length to diameter ratio. Length is 300 and diameter is 250. Ratio is 1.2. Then L by D ratio is less than 1.2. So cup is required. If this value is greater than 1.5, then cup is not required. Remember that. Radius of that cup is 0.7 D is equal to 0.7 into D value 250. You will get the 175 mm. Okay, today we'll stop here. Next lecture we'll see the next remaining part of the design of IC engine is connecting rod. This is the last important part. You will get the some numericals on the basis of connecting rod. Okay, thank you.